Okay, staying in this section one more day. 6-3, day 3. Okay, probably could have squeezed this in yesterday, but didn't really want to have another long day. So, we're going to do a little theorem discovery here first. Our theorem discovery is going to be doing the derivative of a definite integral with the upper limit a variable. Okay, if you happen to forget this little theorem discovery and forget the shortcut, you'll be doing these problems the long way come the quiz or the test. Okay, so here's our discovery. Suppose we're going to call g of x is going to be the function we get when we do the antiderivative from negative 0.2 to x of cosine t dt. Okay, notice the function I'm getting is going to be in terms of x because I'm going to be substituting x into this antiderivative when I work it out. These are not going to match. Alright, so let's just figure out what function g is. Because what we want to do is take the derivative of g when we find it. So we're going to do antiderivative first. So what in the trig world has cosine as its derivative? Well, you know that goes to sine. So it's sine t evaluated from negative 0.2 to x. So when I plug in, this is my function g of x. G of x equals the sine of x minus the sine of negative 0.2. Okay, so I found g. Now I want the derivative of this definite integral function. So now I want to do g prime. So derivative of sine of x is cosine x. This is a constant. I didn't actually work it out on my calculator, but the sine of negative 0.2 is just a number. Sine negative 0.2, negative 0.1986, but the derivative of any constant goes to 0. So my g prime function is cosine x. Well, let's compare that back to what I started with. Do I really need to do these 3 steps to get this answer? Well, take a look. My antiderivative function was cosine t, evaluated from negative 0.2 to x. Well, all it looks like happened was the x got substituted in for the t. And that is what happened. Because if you think about it, antiderivative and derivative undo each other. So when I took the antiderivative and then did derivative again, it got right back to where I started. It went right around the mulberry bush. So the shortcut to this is not to actually find the antiderivative and then do derivative. It's just do the shortcut. G prime of x will equal this function with the upper boundary substituted in. The bottom boundary, as long as it's a constant, goes to 0, and we don't have to worry about it. So this is it's called another fundamental theorem of calculus. Another fundamental theorem of calculus. Remember, the fundamental theorem let us plug the boundaries in and subtract. Let us find the definite integral. Here's another fundamental theorem, which says if g of, and it doesn't matter the letter, of u is equal to the antiderivative from some constant a to upper boundary u, these have to match, of some function, I'll go f of x dx, where a is a constant squeeze that in there, where a is a constant, that has to be a number down there. Then the shortcut to get g prime of u is just to take whatever function I have here and substitute u into it. So it's f of u, and then what doesn't show up is you do have to multiply by the derivative of this u. So times u prime. So that's our shortcut. If they give you an integral and they want the derivative of that, it's just substitute the upper letter into the function and multiply by the derivative of that upper boundary. So let's try a couple, see if you have it. It's a very, very simple, real simple theorem. It's just remembering it. So here we go. We're going to find the derivative. So notice the directions are find the derivative. If f of x equals the antiderivative from 3 to x, so we've got our constant to our variable of sine 3t dt. Okay, I'm looking for f prime of x, not f of x. I want the derivative of f of x. So f prime of x, okay, I know this is a shortcut. All I've got to do is take this, substitute it in here, and multiply by the derivative of this. Well, that gives me sine of 3x times the derivative of this is a 1. It's not the derivative here, but it's up here. So just sine 3x. Done. Couple more. Same directions, find derivative. If f of x equals the integral from -4 to x squared, so we've got our constant and our letters match here, of the quantity t cubed minus 5 to the 4th power dt. Okay, I'm looking for the derivative, not the antiderivative. I could go through to antiderivative and then do derivative, but I don't need to. I've got a shortcut. My shortcut says take this, substitute it in for all of the t's, there's only one t here, and then multiply by the derivative of this. So f prime of x will equal, instead of t, it's now x squared, but that's got to get cubed, minus 5, and then that whole grouping to the 4th, times the derivative of this upper boundary is 2x. So simplifying in here, this is a rule where we multiply. X to the 6th minus 5, quantity to the 4th. I'll throw the 2x in the front. They don't get much harder. You just have to remember the shortcut rule. Let's go -2 tangent of x squared of t squared dt. Looking for f prime of x, not the integral. So the shortcut says take this, substitute it in for the t, and then I have a squared, so it's going to be tangent of x squared squared, but then I always have to remember to multiply by this derivative. Derivative of tangent is secant squared of the angle x squared times the derivative of the angle 2x. So, nothing much I can do here other than pull the 2x to the front. So 2x, if I wanted to eliminate parentheses, I would put my squared right here. So that would be tangent squared of x squared, secant squared of x squared. Lots of squares in that one. Okay, I'll do one more just for good measure, but that's about it. See, we could have squeezed this in yesterday, but I think that would have been a really long day. F of x equals The integral, oh, I suppose, that's alright. 2 to 3x of 1 plus t cubed dt. Derivative is what I'm looking for. Shortcut, take this, substitute it here. Square root 1 plus 3x cubed times by the derivative here, which is a 3. So simplifying here, bring this to the front. 1 plus, let's see, I got to cube the 3, that's going to be 3 times 27 x cubed. Okay, your homework assignment is going to be page 259, 2 through 26, every other even. 28 to 46, all of the evens. And then 47 to 54. Oh. Okay, that'll finally finish this section.